Hello, friends, and welcome back to Technology Now, a weekly show from Hewlett Packard Enterprise where we take what's happening in the world and we talk about how it's changing the way organizations are using technology. We're your hosts, Aubrey Lovell
and Michael Bird. Now, in this episode, we are looking at supercomputers, and in particular, the UK's fastest supercomputer, which is being assembled in collaboration with HPE in Bristol, the Isambard AI. Due to be completed in the summer of 2024, it will be 10 times more powerful than the UK's current fastest supercomputer and one of the most powerful in the world. There's a press release from HPE with those details and more linked in the show notes. Anyway, whilst that's undoubtedly exciting in itself, what does supercomputing mean in the age of AI? How is technology in the field changing to adapt to new demands? And who will be the main benefactors?
So, if you're the kind of person who needs to know why what's going on in the world matters to your organization, this podcast is for you. And hopefully you've joined us and subscribed to your podcast app of choice so you don't miss out. All right, Michael, are you ready?
Oh, I'm ready. Let's do this.
The term supercomputer was first coined in 1964 after a decade of tech companies competing to make the world's fastest computer. The earliest supercomputers could carry out kiloflops of operations, thousands of calculations per second, but technology moves quickly. In the spring of 2022, HPE and the U.S. Department of Energy's Oak Ridge National Laboratory announced that the supercomputer Frontier had broken the exascale speed barrier for the first time. That means being able to solve a problem at 1 billion operations per second.
Absolutely incredible. And we've linked to the HP press release on that in the show notes too. But Isambard AI is different. For a start, according to University of Bristol, it'll be one of the world's first large-scale AI supercomputers. And the UK government has invested £225 million to create it as part of a national AI research resource based in the city. According to the teams involved, it will reach up to 200 quadrillion calculations per second and will give researchers and industry leaders new possibilities in the UK. The opportunity to work with the huge potential AI has to offer in the fields of robotics, big data, climate research, and drug discovery. There's more details on that in a press release from University of Bristol in the show notes. Recently, our roving reporter Alex Podmore spoke to Professor Simon McIntosh-Smith from University of Bristol, and he's leading the unit bringing the UK's fastest supercomputer to life. Over to you, Alex.
Could you just give us a quick overview of what we've recently announced between HPE and University of Bristol?
So we've just announced a new AI-optimized supercomputer called Isambard AI. This is going to have over 5,000, nearly 5,500 of the very latest NVIDIA GPUs in it. And we're going to be using this to support all of the AI research in the UK. And it's a new system that will be going in using HPE modular data center solutions going into Bristol next summer.
So that's quite a quick turnaround next summer. What does it take to get a project like that turned around within, just under a year?
We're building Isambard AI very quickly. We'll have done the whole thing in less than a year. This is much quicker than we normally do systems of this sort of size. And what we've done to go this fast is we've had to really think how to optimize every stage of the process, from how quickly we wrote and ran the procurement, how we're going through planning permission. One of the reasons we adopted the modular data centers was because we wanted to be able to go fast. So we're actually going to be able to build a brand new site, putting new modular data centers into it, and do all of that in just a few months, with a very sort of integrated solution from HP that includes all of the supercomputer technology inside these pods, as well as all of the cooling solution that goes along with that.
Amazing. And you mentioned AI research or research and development powered by AI. What kind of organizations will have access to this national supercomputer?
One of the really exciting things about Isambard AI is it's going to be open to all researchers in the UK. So our funding is coming from the government through our umbrella research council, which is called UKRI, and they fund all academic research in the UK. So any researcher who's looking at using AI techniques, no matter what field they come from, they're all going to be able to apply for time on this amazing new resource.
And so what does national access to a brand new supercomputer mean for research and development?
So we think this is going to be really transformational for the UK. There was a report that came out early in 2023 called the Future of Compute report, and that said we had a real lack of AI compute resource in the UK, and we needed to do something about it urgently. And the government's really stepped up, and that's what's funding Isambard AI, making that happen. And we know there's a lot of research that just hasn't been able to happen in the UK. We've had something like less than 1,000 GPUs sort of openly available for researchers in the UK to do AI work. So taking that from where we are to over 5,500 GPUs is just going to have a step change, we think, for AI-related research in the UK from next year.
So come summer 2024, once this thing gets off the ground, what kind of ventures do you hope or expect to see being kind of worked through this supercomputer?
So we've got some idea of the kinds of things people are going to run on Isambard AI. I was hearing just this morning about some work at UCL where they're doing lots of amazing AI on brain scans and starting to look for anomalies in ways that are more accurate than human beings can. But every day we're hearing about something new. We're looking at people who want to train their own foundational models. We need to be able to do tuning of existing models. And the list just goes on and on of people who come up to me and say, hey, I could use your entire new machine all by myself. So I think there's so much demand that's been waiting for this kind of resource that I'm expecting us to get swamped almost as soon as we're open.
Brilliant. And so in the press release, when this supercomputer was announced, you mentioned something called open science. What do you mean by that?
So because we're publicly funded, one of the really cool things about Isambard AI is all of the work that's going to run on the machine is going to be open science. And that means that all of the results should be published and available for anyone to benefit from in the future. That would mean code that somebody develops or the results of their research or the data they produce on the machine should all eventually appear in public so that everyone can benefit from that publicly funded work. And I'm very excited about that part of the project.
Absolutely fascinating. Thank you so much. And we'll be back with Professor Simon McIntosh-Smith in a moment, so don't go anywhere. Okay, Michael, it's time for Today I Learned, the part of the show where we take a look at something happening in the world we think you should know about.
Yes, okay. And this week, we are talking space.
Ooh, I love space.
Yes. Okay. Well, rocket scientists in the US have tested a revolutionary new engine type which could change the way that we view spaceflight. NASA has performed a firing of a 3D printed engine with almost no mechanical parts. It's called an RDRE, or rotating detonation rocket engine, and basically involves a supersonic shockwave going round and round an engine nozzle, igniting fuel as it goes. Sounds pretty cool. Now, in a recent hot fire test at the Marshall Space Flight Center in Huntsville, Alabama, the agency achieved a new benchmark in developing RDE technology. On September the 27th, engineers successfully tested a 3D printed rotating detonation rocket engine for 251 seconds, producing more than 2,630 kilograms or 5,800 pounds of thrust.
Wow.
So there's a couple of big benefits to rotating detonation engines, but the biggest are that it has less moving parts and so theoretically could be easier to maintain. It's smaller and lighter, and it's up to 25% more efficient than traditional engines. Those are all big factors in space travel and make the engines an ideal candidate for future interplanetary missions, such as travel to Mars. And also, you and me can now say rotating detonation rocket engine, and we can pretend like we know what we're talking about.
And I can say, that's far out, Michael. Thanks for that.
Right, now it is time to head back to our roving reporter, Alex Podmore, with more from his interview with Professor Simon McIntosh-Smith.
Why was Bristol chosen specifically for this project?
So the reason why Isambard AI is going to be in Bristol, there are lots of different reasons. We've got the right people with the skills and know-how and experience to actually build a supercomputer of this size and do it this quickly. But also we had a couple of other really key capabilities. One was we knew we had enough power. And actually having enough power, having megawatts of power is very, very rare. We were doing another supercomputing project already, and so we happened to know we had a site with the power to do this. We knew we had enough space as well. And we were already adopting this modular data center technique. So we knew we could do something quickly, we knew we had space, we knew we had power, and we knew we had the people who could figure out how to do this. So that was the unique combination that came together and why Isambard AI was awarded to Bristol.
Amazing. One final fun question. In an ideal world, what would be the first thing that you would do with this supercomputer?
what would I do with Isambard AI? I actually already have my own idea for the system. So in Bristol, there's this amazing resource called the Brunel Archives, and it's a collection of all the works that Isambard Kingdom Brunel ever produced, all of his writing, and he was a very prolific Victorian engineer in the early 1800s, and all of this is now being digitized. So I would like to train a model based on everything Isambard ever actually did or said in his life, and then I'd like to ask him questions. It'd be a bit like actually getting to talk to Isambard Kingdom Brunel. That's something I would like to do with this system when it's up and running.
Amazing. Well, thank you so much.
Thanks so much, Alex and Simon. It's been great to learn about Isambard AI, and you can find more on the topics discussed in today's episode in our show notes.
Right, we are getting towards the end of the show, which means it is time for This Week in History, which is a look at monumental events in the world of business and technology, which has changed our lives. Now, last week, Aubrey, the clue that you brought was it's 1950 and we'll ping you when dinner's ready.
Mm-hmm.
I don't think either of us had any idea what it was. So,
no.
Should I tell you what the answer is?
Yes, please do.
Now, the script says the word obviously. I don't think it was obvious. But anyway, it was obviously the issuing of the patent for the microwave oven. Oh, wow. Okay. This week in 1950. The patent was issued to Percy LeBaron Spencer, amazing name, under the title Method of Treating Foodstuffs. Which is not a hugely helpful title, but the technology was certainly a hit despite some initial skepticism about health concerns. The idea had come to Spencer 5 years previously when he'd accidentally melted some chocolate in his pocket when working with microwave tubes designed for military radar systems. Not one to be concerned about his proximity to radiation powerful enough to melt food, he found a way to safely box up and commercialize the technology, and the rest is history. Please, please don't microwave your food in your pocket. Please don't do that. Right, what's next week?
Next week, the clue is, we're moving up a decade, 1961, boldly going went bananas. I'm not sure what that means, but we are going to find out
Once again, not a clue. So that brings us to the end of Technology Now for this week.
Thank you to our guest, Professor Simon McIntosh-Smith, and our reporter, Alex Podmore, and to our listeners, thank you so much for joining us.
Technology Now is hosted by Aubrey Lovell and myself, Michael Bird. And this episode was produced by Sam Dattapaulin and Al Booth with production support from Harry Morton, Zoe Anderson, Alicia Kempson, Alison Paisley, Alyssa Mitri, Camilla Patel, Alex Podmore, and Chloe Sewell.
Our social editorial team is Rebecca Wissinger, Judy Ann Goldman, Katie Guarino, and our social media designers are Alejandra Garcia, Carlos Alberto Suarez, and Ambar Maldonado.
Technology Now is a Lower Street production for Hewlett Packard Enterprise, and we'll see you next week.
Cheers.